Right. So we're going to be talking about object diagrams. We're going to go through a few slides talking about the basic rules and notation for object diagrams. And when we finish doing that, we're going to use our the blog accounts, the blog system to discuss that. And then we're going to switch to the example that we started on Monday, which is the example with the clinic. Everybody remembers that? So we're going to switch to that, and I have done a model, a class model, a domain class model inside of Star UML. We're going to use that. We're going to go through it just to make sure that some of the ideas related to class diagrams are clear to you. And then we're going to move on by building an object model or some object models for that class diagram, that class model. All right? All right, so when the system you designed is actually in use, then objects make up its parts and bring all your carefully designed classes to life. So you know that you write your code, and in writing the code, you're specifying classes. But when you execute the program, or when you write the program, you write the driver for the program. When you run that, you instantiate the objects, right? Instantiate the classes. And so the program itself in execution is really a collection of objects that are related to each other in different ways, right? And it has to, the relationships between the objects conform to the relationships that you define in the class, in terms of class relationships. That makes sense? Yeah, the objects can't do anything that the class definitions would not have permitted, right? Likewise, your object diagram is a representation of your system. Your object diagram is a representation of the objects in your system at runtime at a specific instance, right? So the object diagram is not exactly dynamic. It's saying that if you were to freeze the system at a point in time, these particular objects would be alive, and this is how they'd be related. These are the connections that they would have with each other. That's what the object diagram tells us. So class diagrams describe how all of the different types of objects within your system interact with each other. They also draw attention to the many ways that should be object diagrams, the many ways that objects will exist and interact within your system at runtime. So here's a notation for an object. We can name the object without specifying what class it belongs to. So this is an example of an object called entry. We don't know what type it is, but usually you can infer what it is. And you want to have that there because sometimes in your model, maybe while you're modeling an object interaction, which is what the object diagram shows you, you might realize that you need a particular object, but you haven't figured out which class it belongs to. Okay? We can also show the object name along with the class that it belongs to. This is notation for it. And you can show the class type without specifying any object name. So we call this an anonymous object. Right? Now, the other thing, what else do you notice about it? You notice that it has a formatting similar to the class formatting, right? What makes it different? What else do you see? We underline the name of the object or class or whatever it is we're using to identify the object. We underline that. What do you expect to see in terms of attributes and operations for objects? Yeah? Can't hear a word. Anybody hear what he's saying? What about you who you're right in front of you? Can you hear?
We have the attributes of the classes.
Okay, it will have the attributes of the class that it's defined from, correct? But what else? What specifically about the attributes? Do you expect it to look the same way as it looked in the class diagram? Why? What do you expect to see? You expect to see the state of the attribute. So an object diagram is showing specific instances. So those specific instances, and you don't always have to show all of them. You show them based on what's important for the particular scenario that you're modeling. But for example, if you have a student class and you do an object diagram with a student in there, then you can put things like the literal name of the student, the literal ID number of the student, the literal phone number of the student. The other thing that we want to think about is the relationship between objects. In an object model, you can show the relationships between the objects, and they're called links. And that's basically the only kind of relationship you show between objects in an object diagram. Links represent places in the class. Okay, every link between two objects can only exist if there was a relationship, either association, composition, or aggregation relationship between the two classes that those objects are instances of. Follow? That means that if we have UI is an object, a user interface object, or user interface instance. Everybody seeing that? And we have entry, which is a block entry. If in an object diagram we have this relationship, then it means that there must be some part of our class model that shows user interface as a class related in some way to block entry as a class. Otherwise, this doesn't make sense. Yeah? So links between objects on an object diagram show that the two objects can communicate with each other. A link can exist between two objects only when there was an association or stronger relationship between their corresponding classes. Links between objects correspond to associations between the objects' classes. This means that where constraint rules have been applied to an association, the link must keep those rules. So, rules like these, for instance, a rule that says that one blog account has 0 or more blog entries. It would mean that you can do something like this in your, it means that you can, in an object diagram, you can have D colon blog entry D2 blog entry you can have this account of blog account type. And this means, this is legal because we're saying that we have a blog account called ACC, which is associated with 2 blog entries. Does that make sense? Right. So we're saying that this is valid, and the reason why it is valid is because we are saying that we have this blog account referenced by ACC. That's the name of the account. And we'll have it associated, we'll have it connected to, these are objects. Let me just make sure I'm underlining them some kind of way. So those are objects, all 3 of these are objects. And we're saying that this is a valid object model when we look at this relationship, because this relationship tells us that a blog account must have 0 or more blog entries. It also tells us that if we just had a account by itself with other relationships and no blog entry, that would be fine as well. So the point is that the object diagrams, they're pretty simple. What you're saying is, what are the possibilities? And usually you do this in your design documents. Sometimes you might use it in requirements documents. You usually do it because you want to give a sense of what, what you expect to be the runtime expression of your system in particular scenarios. So sometimes you'll see object diagrams associated with a particular scenario, as in a scenario of a use case. And they might show more than one object diagram to say that, well, both of these are valid situations under this particular use case or this particular user requirement. Understand? Covering multiple scenarios. Okay, so when a blog entry is added to a blog account, it will be grouped under 1 or more categories. When we spoke about this when we're looking at the association relationship. Oh yes. How many people looked at the video? My God. So you don't know what I'm talking about. Did you look at the video from last week Wednesday? Yes. Yes. Okay, good. So you saw class diagram. You have seen class diagrams. And you saw that how many people looked at the video? Put your hand up, let me see. Okay, so you're going to have to look at the video before you go to your tutorials next week, or you're not going to know what to do. All right? Oh, so that I was talking about association relationships. This is an association class category. This line represents an association, right? The relationship between blog entry and blog account is considered an association. Everybody knows that, right? This class, this dotted line connected to a class, it represents an association class, and you can do that in StarUML. StarUML has that feature. Not all modeling tools will allow you to do association classes, but StarUML does. An association class is basically a class that exists because of the relationship, because of the association relationship. So if we were to say that blog accounts are associated, every blog account must have a category, and every blog entry also has a category, and blog accounts can have multiple blog entries. Then you can see that there's going to be a set of categories that relate or that map between a particular blog account and a set of blog entries. Does that make any sense to you? Yeah. So that's called an association class, and you see it sometimes. You'll see from time to time. You don't have to necessarily model it this way. You can just model it with plain association, just putting in additional lines. But this is considered to be like one of those shortcuts that we can use in modeling classes. Okay, so based on this diagram that we just looked at a while ago, here are some valid object diagrams. One of them shows that a blog account contains one. So there's this specific blog account called account, which contains this specific blog entry called entry. Making sense? You have to remember that the object diagram is showing literal instances. It means that we don't expect to see multiplicities on an object diagram. We don't usually put multiplicities on an object diagram. What you do is you actually draw the literal situation. So you're not going to show a range, because multiplicities normally indicate a range. So over here, we would see that there's a rule or a constraint that says that one blog account can have multiple blog entries, right? Everybody sees that? You don't show that in an object diagram, because an object diagram is not showing a range of possibilities. It's showing a literal scenario. Yes.
What if in the literal scenario they have
That's what I was showing you earlier on. You draw them. So for example, you have V here and V2 here as two blog entries. I need right. As two blog entries. So both of these are blog entries. And this is our one blog account associated with those two blog entries. So you show the literal thing. So if you want to show an example of it, so it's like being able to show an example. So if you want to show an example of a blog account held by, what's your name?
David.
So let's say we want to look at David's blog account, and he has 50 blog entries. You can show the 50 blog entries if you want to. If the rule did not say any amount of blog entries, suppose it said that an account can't have more than 10 blog entries, then that means that 50 would be incorrect, it would be invalid, right? And in another week or two, about week after next in your studios, we're going to look at a tool called Views that will allow you to model your classes, to do a class model, and then create object diagrams and check for their validity under all the rules that are in a class diagram. Now this is very simple because we're only looking at 3 classes, and there's just like 2 rules that we need to talk about. Basically, one rule we need to talk about. When you have a bigger class diagram like what we're going to look at shortly, then you really do need to ensure that the things that you're saying in the class diagram, the rules that you have put in, are consistent with what you really want. And you want to ensure that object models that you create, which represent your expectations about how the system could manifest itself at one time, that they're actually in accordance with the class diagram that you have developed. So the second one shows a single blog account that contains a single entry. And it also shows that the blog account has a category. That's also valid. Why is it valid? Because if you look back over here, this association class tells us that blog account is also associated with the category. Now, if you were to modify the class diagram, remember earlier on we spoke about object constraint language? Oh, right. You didn't watch the video. So, object constraint language, or OCL, can be used in a class diagram, and you also see it in state diagrams as well. But primarily, talk about them, most of it is in class diagrams, and it allows you to be able to specify constraints in the context of different elements within the class, within the model. So in this case, our context is this blog entry here, and we're saying that self means we're referring to the blog entry itself. You notice that the constraint is directly linked to the blog entry. Yeah? So self.category means the category that is in blog entry. Because there's a category in blog entry. It's related by association. So that's by association. So that's why you're not seeing it in line. Okay, again, you need to watch the video. You watch the video. Remember, we spoke about inline attributes that are represented inline versus those that are represented by association. And you saw the code that it really is exactly the same thing when you're coding. But it's just that in UML, you have the option of showing both ways so that when you're looking at the diagram, you can see that certain things are primitive data types, whereas others are classes that are being defined in the model itself. I feel like I might be talking gibberish to you. Why didn't you watch the video? That's not fair. I spoke to myself for over an hour for your sake. Okay. So this is self.category, not empty. It means that the set of elements in category cannot be empty. There must be categories. Understand? If we look back at this diagram, if that constraint is there, then this diagram would be incorrect. Only this one would be correct. Right?
Yes.
Right? Okay, so actually to get up and jump and spin around. Come on, people, wake up. Snap out of it.
Yes, miss, we see that one.
Was there a question coming in from Cave Hill or somewhere online? I think I heard something. No? Right, so because this diagram actually does not consider categories, then that means that it would be incorrect. It actually doesn't include that. So the point is that if you do this, if you put this constraint here, it means that a blog entry cannot exist unless it has at least one category. No, this one will be fine because this one already has a category. In an object diagram, so in this object diagram, we can see that a blog account contains a category. It also contains a blog entry, and the blog entry, every blog entry must be assigned to a particular category. Okay, can you see this? I was going to the video. All right, so if you can take 1 minute and just open up back the document that we looked at on Monday. Remember that example we looked at on Monday? And let's see what we can say about this graph diagram. Now, this diagram doesn't have any operations, it just has some attributes. And it has even left out some of the classes. All right, what do we call, let's talk about these relationships. Explain to me the relationship between contact and patient, between patient and contact. What's that relationship? What's happening there? So one patient has one contact. So basically we know that there's a one-to-one relationship between patient and contact, and it's called patient contact. That's all it tells us. What about the relationship between patient and docket?
One patient.
Same type of thing. Now you can clarify which direction you want to. If you wanted to add navigability, you could. So you could also, I could also put in this an arrow like that that says patient has patient contact. And I can also do this to talk about the nature of the association, the nature of the composition. So if I want to, I can actually see that, well, what does that empty diamond, unshaded diamond represent? What's that called?
Weak aggregation.
Aggregation, right. When do you use aggregation versus composition? Owns it permanently, and if you destroy the patient, then the contact information will be destroyed with it. So when you want to choose between aggregation and composition, you ask it, but the side that the diamond is on is a container. That's the higher level of the hierarchy. And then the other side is called a contact. Sorry. The other side is what is contained. So this is actually saying that a patient contains a contact. No. With this contact information object, because that means that in runtime, when you have a patient object, you have a contact object inside of it. With that contact object, would you want to share it with any other patient? No.
No.
So therefore, this is composition and not aggregation. Make sense? Okay. Likewise, the docket, the patient would not want to share it with anybody else. So we're going to put that shaded diamond there. Make sense? All right, some others are in place. So let's look at this one, the relationship between visit and docket. What's happening there? Cave Hill, please feel free to jump in and answer questions. Are you guys there?
Yes, we're here.
Good, all right. So feel free to ask questions. Somebody has their mic on in the room? Anybody in here has their mic on? Okay. Make sure your mics are muted. All right, cool. So what's the relationship between visit and docket? All visits have a docket? Wrong. One chance. Huh?
Someone here was saying one patient to one docket.
I think so. Andrew, I think maybe more than one person has on a microphone in that room or something. There's a lot of echoing when you talk.
Yeah, someone here was saying it's one person to one docket.
No, we're looking at the relationship between docket and visits. One docket can have many visits, 0 or more visits. And that sounds like reality, right? If you go and set up your record with the hospital, if you haven't visited yet, if you haven't been sick, if you haven't gone there for anything, then your docket will be empty. And every time you go there, they'd add another record, another visit information to your docket. And the docket belongs to only one person, one patient. Yes, Renaud. Come again? Okay, so the question is, why do we have aggregation as opposed to composition? Why do we have aggregation? What do you think it should be? So tell me what you think it should be. Oh, there's a question. Go ahead, Renaud. Right, one docket to 0 more visits. That's correct. In Rajni, everyone, yeah, Rajni. Romaria says 1 patient to 1 docket aggregation. Okay, yeah, 1 patient to 1 docket. That's fine. And then Green says the docket can exist without a visit, therefore aggregation. The docket can, okay. So really and truly, any visits that go into the docket should not belong anywhere else. But there's one consideration. If the docket is destroyed, all the visits will be destroyed also. So this would best be represented as composition because the visits would belong to a docket. One consideration that you'd have to make, well, this depends on the analysis process that you go through. One of the things that you would want to ask yourself, so I would agree, this should be composition, I have no problem with that. But if there are other, you want to think about whether or not there are any possibilities of other objects that need access to those visits. That need to share access with those visits. So that's a question that you could answer. But this will be fine as composition. So whenever you have that question, if you have a question mark with any of those things, you can actually always use aggregation or you can leave it as a plain association. Okay, so our next relationship that we want to talk about is this one, between visits and treatments. Or the other thing I should ask you, yes? Zoom what? Oh, sorry, it's anyway, I'm so sorry. All right, so what can you say about this part here? The fact that we have these minus signs on docket and visits.
Private.
It's private, what does that mean in terms of how you would implement this? Why is it private? Right, so visits is actually an attribute inside of dockets. It's an attribute, and we usually want those to be private. We don't want to expose how it's implemented and all the details of it. Likewise, the same for dockets inside of patients. We want to restrict how other classes can access them. All right, next. Ouch. Okay, so what's this? This part you should be familiar with. This relationship here, what's that? Generalization, specialization, relationship, or inheritance. It basically means what? What's happening here? Pediatric, geriatric, and obstetric are all is a visit. Right, children of is not the best way to describe it because we can also look at aggregation relationships as there are hierarchical relationships as well. The main thing you want to make sure is that there is a relationship. So for clarity, we could have called these, instead of pediatric, we could call them pediatric visits. Geriatric visits. It would kind of be a little more obvious what kind of relationship we're talking about. Then let's look at the relationship between visit and test, visit and symptoms. Quickly.
So one visit can have multiple tests and tests.
Okay. Then over here, what's happening over here? This relationship here.
One test has one test type.
And what is test type?
Test type
Is that? Is that? Right, it's an enumeration. And it means that you just basically have a set of literal values that the particular attribute can now take on. The test type can be an X-ray, ultrasound, and so on and so forth, right? And the one-to-one relationship here means that test type, there can only be one type of a test. But let's look at this one. Diagnosis, the relationship here from diagnosis to related symptom.
So, one diagnosis can have
Oh, sorry, not symptoms, systems. I'm sorry.
one diagnosis can have
Right, so every diagnosis can be related to any number of systems. You can also specify that enumerations are static, and they would look like this. And if they are static, it means that the number of, you can't add anything to the list of values inside here, the list of literals. Here's another question. Why can't the type of visits be an enumeration? The type of visits can be an enumeration. When you refine your, I deliberately left it at that because somebody said it in the class on Monday. I deliberately left it like that because the document actually says that there are special processes that vary from, the processes vary across the different types. Now, if it is that when you go into the details of your design, you realize that you have a specific processes or methods that you need to include in one, but not another, then you might want to stick with inheritance. If you use the enumeration type, it means that you're going to have to check the type of the visits in order to apply the particular behavior. Do you understand what I'm saying? You're going to have to say, if it is a geriatric visit, then do these things here, show this particular screen, include this particular field, and so on and so forth. Whereas if you use the different types, then you implement polymorphism in such a way that any visit would know what type it is and be able to do whatever it's supposed to do, right? Now, if it is that when you're going to the details of your system, you realize that you really don't have much differences except that you want to be able to flag them, then an enumeration will be perfectly satisfactory. I hope that answers the question to Lawyer online. Yes. No. Yeah, that's how you show that it is static. Yeah, that's right. So usually, like in star UML, to show that something is static, it usually has a field available in the properties section that you can check and it will automatically underline it. But I could not find it. But I didn't need it for this anyway. I'm just saying that to show that something is static. That is, for example, let's say we should have recorded gender as one of the personal details for the patient, right? There are only two genders, male. There are only two genders, male and female, right? And so in that case, you wouldn't be adding anything to it. I think now in the States, they have something else, like they call it, what do they call it in the States again?
Non-binary.
Non-binary, they have that. You can also put unspecified. Yeah. So the point is that when you know exactly what the possible values are and you're not planning to add any additional values at runtime to the enumeration, because sometimes you need to do that, then you can do that. Yes.
I would tell them about how we need to call it specialized.
Okay. All right. Let me just pull this back down. Yeah, so enumeration will be perfectly fine. As long as you're not, all of these things are design choices. You have trade-offs. You have to decide. So it could be an enumeration, but if it's an enumeration and you find that you have significant differences in the business processes associated with a geriatric visit versus an obstetric and so on, then what you will find happening is that you have a lot of case statements or if then else statements for certain behaviors. What else did I want to show you? Okay, we have the purpose of the visit. Okay, what's happening in this relationship here? Explain this one. Same type of thing. A visit can have should have two purposes. This should not be two. This should be 1 to 2. A visit should have at least one purpose, but no more than two purposes associated with it. And that's just an example. So in real life, when you do your requirements and you analyze your system, you might realize that person say, like I went to a doctor one time who told me that I could only tell him one problem. And if I want to tell him about my other problem, I must make an appointment and return to tell him the other problem. So it depends on the business model that they're using, because some businesses run that way. So you just have to think about those things. What else? Look at treatment. Do you think that this is useful or worthwhile to use inheritance for type of treatment? So we see right here that visits can have zero or more treatments, right? Associated with it. So in other words, if you go to the doctor can tell you, well, you need to take this tablet 4 times a day for 2 weeks, and you need to drink this liquid once a day for so many days, and you need to take this vitamin for the rest of your life, and you need to take this other pill for the rest of your life, and you must also walk 3 times a week for 30 minutes, and so on. And you can also, as of now, you have to have some ginger tea every morning or something like that. Those are all recommended treatments, right? But there are different kinds of treatments. So it could be useful to separate these into different types. All right. So the next thing, yes. Could you have put these in an aggregation? How? You mean just like put inside a type that says type of treatment or something like that? You could do that. You could do that. But then if they are very different, for example, exercise does not have a chemical name or pharmaceutical company or side effects or contraindications. And home remedies might have some contraindications, but they certainly don't have pharmaceutical companies and so on associated with it. So you wouldn't have a prescription linked to a home remedy or exercise. So that's why I separated them in this case. So it's useful to separate things. Once you can set the business processes and the rules that are associated with them, and the kind of methods that you want to introduce are going to vary, but there's a common core. And that common core is found up here: the name, dosage, duration, and frequency. That's very applicable to exercise as well as home remedy. Yeah, but these other things here are only relevant to medication. Any more questions? All right, so next thing we're going to do now is think about some object diagrams. We have about 5 minutes left. So anybody wants to try an object diagram and share with us quickly? In fact, I could. Anybody wants to try and do an object diagram for this? Let us consider what an object diagram might look like at the end of an object diagram for a particular patient and the patient's record and so on at the end of registering a patient, and another one at the end of a patient's visit. What do you expect to see? I can't see my. I can no longer see my class diagram. All right, so we have a patient. right, so we have a patient. What do you expect to say associated with the patient? If the patient is registered, then the patient should have a docket, right? And the patient should have what? I want to see the class diagram. All right. What else? That's all? What else?
Yeah, just for registration.
So this would be the case, and this is valid if it is that the patient has never been seen by any doctor yet. Then they would have an empty docket. I can't. What else was on the class diagram? A who? Well, let's look at just the case of the patient being registered. It's a new patient and they just got registered, so they haven't seen any doctor yet. So you have to consider those cases. So when you're putting the point here, is that when you put in the multiplicities on the class diagrams, you have to think about all the possible situations. So for instance, if it is that registering a patient could take place without creating a docket, then instead of 1 to 1, we need to put 1 to 0 to 1. Understand? But we have 1 to 1, so it means that a patient cannot exist in the system unless they have a docket. So that's how you have to think when you're doing the class diagrams. And you're using the object diagrams to validate what you're thinking and to check back. So we're okay with this. What else? Is there anything else that must be there when a patient is just registering? I am sorry, forgive me, I cannot see the class diagram right now while I'm doing this. The patient must have contact information. Right, so we have that there. All right, let me switch. Right, but there are no visits right now. All right, let me just look back at the. All right, so we have this, the patient, we have the patient's docket, we have the patient's contact. All these other things come about only once a visit occurs. So therefore, we wouldn't see them at all. Now, let us modify the object diagram in consideration of at least one visit taking place. So let's say that the person has only visited the doctor once, and this is at the end of the visit. If we were to bring up that person's data, open that object, what are the objects that would be instantiated? So say that we'd have a visit, right? You notice that we're not using right or anything like that. And we don't use any multiplicities or anything. These are called links. Objects are linked to each other, so they're not associated per se. But the links are like instances of association relationships. What else will be there? So we'd have a time in there, so you can have literal data in there. So Monday, the 5th of July at 5 p.m. or something like that. Right? What else? The name of the doctor, so we could have, I don't know, was physician name, was the name of the field? And you'd specify the name of the physician. What about other links now? Type of doctor. We didn't have that in our class diagram, did we? So what we need to ask ourselves now, what kind of visit is this? So what you'd have up here is not the visit type. You'd have the specific one, unless this is general. So let's say it was a pediatric visit, then what you'd have here, the class type would have been class type here would have been then the visit has associated with it. If there was some tests, remember that's 0 to many, so there can be 0 tests, or there could be a test. So if there's a test, you'd specify the type of the test, yeah? Very good question. What about it? No, because a visit cannot be all 3 types. A visit must only be 1 time. So you're looking at runtime. Remember, in runtime, every object has to manifest with only 1 type. Yes, and the specific type is pediatric. So in other words, the instance of the visit class, that the type of visit class that was instantiated was a pediatric visit. It could have been the regular visit, or it could have been obstetric, or it could have been geriatric, but it can only be one of them, because this is an object diagram. So we're not to say inheritance in the object diagrams either. Exactly what that was. So this would say, for example, for patients, you would have name, and you don't have to show all of them. And you don't have to show any other attributes either. You just show 1 or 2 based on what you're trying to express to illustrate that, okay, here is Mary Brown. So you can put that in. You can put in our date of birth or whatever it is, just to give that sense of, okay, this is real time. This is what this is an instance of something happening in runtime. So you're showing objects. There's no object that has multiple types. So you have to decide which one of the data type, which one of the types within the inheritance family you're going to let this particular visit be. So we selected pediatric. Yeah. Oh, sorry. What else you want to put in? You want there to be any treatments, or the person is okay and you want to just send them home without any treatments? They are okay, so they're not getting any treatment. Okay, what else did we have? If purpose of visit or something like that. That was an enumeration, right? You can, for this you can just put, oh Lord, I'm sorry. So for that one, you can just put it in here. The name of the, what was the name of the attribute? On the relationship for purpose, what was it called? No, what was the name? No, not the type. The name of the attribute itself, not the values. It was reason or purpose. Okay, let me explain something to you. Let's look back at this. You see this? Visit purpose. This is the name of the attribute. When you actually write in the code, the attribute that will be inside of visit will be visit underscore purpose. You see that? And you're going to end up with something like visit underscore purpose is being equal to one of these values. Either checkup, medical need, diagnosis, or follow. So if you switch back, then we can have purpose, visits, and you can specify the type as well. Anyway, equals checkup, for instance, and so on. I'm going to do something now because it's after 10 actually. Okay, at persons online, any questions, anything? I realize I've gone over the time, so I'm going to stop here. All right? Bye.
Actually, he's a real person.
Okay, have a good day. Bye-bye.
What a terrible one. Like,